Guys, continuing with the same problem. So I'll rewrite the same problem again. This is an element in a structural body which is experiencing this type of stresses on the body. So it is experiencing 100 Newton per m square along its direction. It is experiencing 40 Newton per m square in the y direction. And it is experiencing some sort of shear stresses like this. And the shear stresses are only mentioned at one point. So the value of the shear stresses will not change on every surface. If one surface is applied with the shear stress, complementary shear stresses are automatically developed. So complementary, the word means it comes free. Okay. So that way it has the same value. Suppose if this problem is given in the internals or in the examination and they ask you to solve for the normal stress at any angle theta, that plane may be something like this. It may be 50 degree or 45 degree or anything, and it is not a vertical plane, it is at some plane to this. They want this at an angle. So they want the normal stress and the shear stress in this plane, which is in this plane. Now which is at an angle of theta. Then how you should solve the problem is the question. So we will show you how to do it. So first you should do it. Now what you should do is you should actually draw x and y line as previously drawn. Okay, and then draw y-axis, positive tau, negative tau. This is positive sigma, negative sigma, and locate 100 mm, 100 Newton per m square, and this is slightly less than half of this, 50. So this is 40. So this is 40 Newton per m square. Guys, you can't casually mark like this. You have to do it with exact precision because you are getting the values from here. Okay, so you have to actually take the values from here and then get the answer. Maybe I will actually show you how to do that. So 40 and 100 is marked, and then in the previous case the shear stresses were not there. Suppose if the shear stresses were not there, then what will you do? ಬರೀ 100 ಮಾತ್ರ 40 ಮಾತ್ರ ಕೊಟ್ಟಿದ್ದು, shear stress ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ ಏನು ಮಾಡ್ತಿದ್ವಿ ಲಾಸ್ಟ್ ಟೈಮ್? Now what is the next step that we will do? Find the center and draw a circle. Okay, now we are not going to draw a circle now because the shear stress will add the value of the normal stress. It will add to the value of the normal stress. So what we should do is we should look at the direction of the shear stress in the positive x direction, and if it is upwards, then the same value of 40 has to be taken downwards here. Whatever the 40 that you have taken here, no, the same 4 centimeter has to be taken here downwards. Okay, got this point? If it is going above here in the x direction, in the positive x direction, that has to be taken in the opposite direction, and exactly on the other side it should be drawn. Okay, it will be on the, it has to be drawn on the opposite side, which is again 40. So once you have drawn this, then you should draw a line which actually meets, which actually connects these 2 points, somewhat like this, somewhat like this. Okay, so this line is trying to connect these 2 points. So what you have done now, 40 Newton per m square you have located, 100 Newton per m square you have located, then this 40 shear stress is drawn here, and this 40 on the other side is drawn above, and these 2 points are joined and you get the midpoint. And with this as the midpoint, then you should draw a circle. So once you draw this circle will be definitely bigger, otherwise the circle would have been this size. Now the circle is quite larger, the circle goes like this. The circle must pass through this 2 points. You should keep the compass here, you should draw like this. So it will meet, it has to meet these 2 points, and then you should draw a circle like this. Now once you have drawn the circle, almost 80% of the manual work of drawing the circle, drawing this over. Now getting the values from this more circle is the question. And also we need to relate this to the equations. Okay. Okay, now here, what is the maximum normal stress? Can you tell me what is the maximum normal stress? Okay, how do you find the maximum normal stress? Maximum normal stress means what is the location on the circumference of the circle which has got the highest value of sigma. Is it the value? Is it the value? Now what is this value basically? Minimum. So this refers to minimum. So I can say this as minimum. So minimum is referred to as sigma 2. Yeah, that's good. Sigma 2. And which is the maximum? Sigma 1. Where is it? It is here. It is here. Okay. Sigma 1 and sigma 2 can be got here. Now, maybe in the graph or in the diagram you can say, suppose if you measure 1 more centimeter here and again 0.5 centimeter here, then what will be the value? Suppose if it is 11.5 centimeters, what will be the value here? Suppose this point comes to 11.5 centimeters, what will be the value of sigma 1? 115 Newton per mm square. Okay, like that you should be able to measure. But you don't have to do that. Okay, if you want to do that, you can definitely do that. Examiners will not penalize or cut marks for writing wrong values because people are choosing from the graph. When you try to draw, there will be small amount of errors. But when you are doing it in equation, since you are using calculator, the errors cannot creep in. So they expect exact values. Can you draw this? Guys, can you actually make an equation to find out sigma 1 and sigma 2 in terms of sigma x, sigma y and tau? Can you actually make an equation to find out sigma 1? Okay, what is this value, guys? Can you tell me what? How can you actually give this value as? Can you do? This is 70, which is the average value between 100 and 40. So which you can actually say it as this value is definitely sigma x plus sigma y divided by 2. Okay. Guys, then what is this basically? This is actually tau. This is actually tau. What is this, guys, basically? What is this? What is this distance? Yes. Thank you. Otherwise, I will lose confidence in teaching. Okay. This is sigma x minus sigma y by 2. This is tau. Then even 8th standard students will say, what is this? What is this? Radius of artery. Knowing these two, then what is this? Okay, how do you define hypotenuse? So hypotenuse square is equal to the sum of the adjacent square and this. Suppose if you want the radius now, if you want this radius, now this radius can be turned, it goes up to here. So if you want the radius, now this radius is nothing but under the root sigma x minus sigma y divided by 2 whole square plus tau. People write it as xy because it is acting in the xy plane. All these numericals that we are solving is on a plain board. X-axis, y-axis, no z-axis. Okay, so we are only having planar stresses. Okay, so people write it as tau xy. They simply don't write it as tau. They write it as tau xy, which refers to shear stress in x and y direction, x and y plane. Sorry, x and y plane, xy plane. I am using wrong words. Okay, so tau xy here. So you should definitely know that this is nothing but the root of this side square and this side square. So can you tell me then what is this sigma 1? So can you tell me what is sigma 1 now? Sigma 1 is nothing but, so sigma x plus sigma y by 2 plus this plus radius will give you sigma 1. So if you don't want to solve it by Mohr circle method, then you need to remember this equation, which will give you directly the value of maximum stress. And the sigma 1 is called as the principal stress. If you actually look into the internet for principal stress, they state it as a principal stress is a stress in a plane where there is no shear stress. Where there is no shear stress. And it happens that only on the x-axis there is no shear stress. If you go above, there is shear stress. If you go below that, there is shear stress. Only on the x-axis you will find the maximum normal stress with no shear stress. So usually this point is the maximum normal stress. Okay. Now, so once you have done this, then people draw lines like this, and then they actually write it as this plane sigma. So that means now this plane is actually here. Now this plane is actually here. And if they wanted the plane which has the maximum normal stress, you can find out with this equation. And if you want the minimum normal stress, now what equation you will use? Maximum ge add madre, minimum ge madbeku minus madbeku. So this value minus this value will give you minimum. And if you want the angle at which the maximum normal stress is from this, antandre this is 2 theta. Okay. So can you actually say, can you use, since you know this side, can you calculate this, can you build a relationship between this and this side? Will you use sine for this? Will you use tan? You can use tan 2 theta, you can use this as tan 2 theta is equal to, what is actually tan theta? Opposite by adjacent. Opposite is tau xy, adjacent is sigma x minus sigma y divided by 2. Okay, so if you want actually theta, so that is tan inverse of, so tan inverse of what? Tau xy, and this, now this 2 can come above 2xy, so you can first find out for 2 theta, otherwise it will lead to confusion. Sigma x minus sigma y by 2. So like this, you can actually find out, like this you can find out the values for this theta here. Okay. So you can say that from this plane, from this plane, at an angle of this 2 theta, here it becomes theta, you will have the maximum normal stress. So you can say that maximum normal stress, you can again write sigma 1 is at an angle of theta, whatever the value that you got here has to be written here. And once you have got this value here, this value is 180 degree in this diagram, but actually it is 90 degree here. So whatever the value of theta that you got here, so sigma 2 is at an angle of theta, which is whatever the value that you have added here plus 90 degree will give you the value, because it is exactly on the opposite side. Okay, like this you have to write this. So now what you have found out in this problem? Maximum normal stress you have found out, minimum normal stress you have found out, at what angle the normal stress, the maximum normal stress is you have found out. And then you have not found out something, the maximum shear stress, which is very easy, which you have already found out, but you don't know that you have found this out. Can you tell me what is the value of maximum shear stress here? Maximum shear stress, what is the value? Where do you find this maximum shear stress? You should actually go to the topmost circle and then do this. When you do this, you know that this is nothing but the radius. The radius is already this. So, if you want the maximum shear stress, which is actually called as the tau max is nothing but root of sigma x minus sigma y whole square divided by 2 plus tau xy whole square. So you just have to know this radius. You may measure with this diagram here. Suppose definitely it will be more than 40. 100 minus, it will be definitely okay. Ikkada 30 iddu, ikkada 40 idre, this will be 50. A 3, 4, 5 rule. Okay, this will be 50. So this will be actually 50 Newton per m square. Okay, so you have to write here that if you are doing it with equations, you should use these equations. Don't have to do this. But sometimes people may ask you to do it with more circle and confirm the answer with equations. Okay, so what and all you have done? Sigma 1 you have found out, sigma 2 you have found out. What is the angle at which the sigma 1 and sigma 2 occurs? You have found out here, and then you have placed it here. Then what is the maximum shear stress? You have found out. Maximum shear stress at what angle the maximum shear stress occurs also can be found out by measuring the angle for this. You measure the angle. Suppose if it is actually 45 degree plus 90 degree. So much it is? 135. So this theta is 2 theta is 135 degree. So theta will be 62.5 like this. So you can say that shear stress is maximum at theta is equal to 62.5 degrees. In this way you have to write. Okay. Okay, this is not the end, because they would have asked something else in the problem. They would ask you, what is the normal stress and the shear stress at an angle of theta is equal to 30 degree here? Then what will you do? Apart from asking you to find sigma 1, sigma 2, what is the angle of sigma 1 and sigma 2? What is the value of tau max? What is the angle of tau max? Apart from these 5 values, they will also ask you what is the normal stress at an angle of theta is equal to 30 degree? What is the shear stress at an angle of 30 degree? 7 parameters you will have to find out. The last two which is asked in the problem, how will you find out? For that, what you have to do is, it is, suppose if it is given as 30 degree here, then you should not draw 60 degree from here, because the reference line is now here. The reference line now is here. Suppose if this is inclining like this by 30 degrees, here you should incline it by 60 degrees here. And then, suppose if it is actually inclined by 60 degrees here, suppose if it is inclined by 60 degrees here, then you have to incline it by 120 degrees here. So 90 is so much, and 120 degree approximately like this. Now we get this point. So once you have got this point, then what you should do? Then measure this horizontal distance. Horizontal distance can be measured in the graph here, because this will be 70, 80, 85 or something, and vertically this will be less than 50. So you can say that sigma at 60 degree is how much? Somewhere around 85 Newton per mm square. And then tau at 60 degree is equal to around 45 or 40, something like that, 45 Newton per mm square. The value that you are writing depends on how precisely you mark this. Suppose if you don't want to do this, and suppose if they have not asked you to use the Morse circle, then you have to use this equations. So the equation is, you can add. So earlier we used this equation. I hope you remember the equation for sigma x and tau. No? So what is the equation, guys? Earlier we used this. So there is no place to write here. So can I erase this equation? I mean, can I erase this point? Sigma at any angle theta is equal to sigma x plus sigma y by 2, sigma x minus sigma y by 2 cos 2 theta, and tau xy sin 2 theta. Guys, earlier you had only used this part of the equation because it did not have the shear stress. Since you have the shear stress, you added this part of the equation. This part of the equation will give you directly, without doing the circus of Morse circle, you simply substitute the values of sigma x as 100, sigma y as 40, tau as tau here you should take it as positive or negative. Can you tell me as per the rule? Last time I said that. Like this, if it is there, it is positive. So now as per that it is positive. Here this value has to be taken positive. Suppose if this was like this, then it has to be taken as negative here. Okay, here. Okay. So you can use this equation. And similarly, shear stress at any angle theta will be given by the equation sigma x minus sigma y by 2. So cos 2 theta, and then tau xy, sorry, this is sin 2 theta. I keep forgetting this equation. I think this equation was already there last time. Use this equation because tau xy is always the sine component. If you want vertical distance, it is sine component. We got this. This was radius. The radius to sine component was this tau, and then this minus tau xy cos 2 theta. So using these two equations, you can get this. Okay, so either you can do this in Morse circle or you can do this with equations.